Today I'm going to be going over a few different concepts in statistics, including the comparison of mean and median, how to find the 5-number summary, outliers, box plots, the 68, 95, 99.7 rule, and finding values given a proportion. It sounds like a lot, but I'll be giving you step-by-step explanations for each problem. Starting off with problem 1, we are given a set of data with house prices in a small town. Using this data set, we are asked to find the mean and the median. We're going to start out with the mean, which is just the average of a set of numbers. To find this average, we simply add all the numbers together, which gives us 1,796,000. And then we divide the sum by the total number of terms in the data set. So all you have to do is count how many numbers there are in the data set, and that is how many terms. So then we take that number, divide it by 1,796,000, and we get our mean, which is 224,500. Moving on to the median is the middle value in a set that is arranged from smallest to largest. Usually our first step would be to rearrange our data, but luckily it is already in ascending order. Now we just need to find the middle terms, which in this case is 145,000 and 150,000. Now we need to find the average of these two numbers, the same way that we found our mean. So all we have to do is add 145,000 and 150,000, and then divide by the number of terms, which is 2. This gives us our median, which is 147,500. Now that we have our mean and median, we're going to move on to number 2, which asks us to state which measure better represents a typical house price here and explain why. So we can look at our values for mean and median and see that the mean is significantly larger than the median. This tells us that we have a term in the dataset that has pulled our mean higher, which in this case is 800,000. This means that our median is a better representation of the center of our data. This is because when we have values that are significantly larger or smaller than the rest of the data, median is better because it is not pulled one way or the other. This brings us to number 3, which asks for us to explain how the outlier affects our answer. An outlier is basically just a data point that is significantly different from the other numbers in the dataset. Just as I was talking about in number 2, the outlier of 800,000 pulls the mean way higher than what most houses actually cost, therefore telling us the median is a better representation of the center. Now that we have completed problem 1, we can move on to problem 2. This one gives us a set of exam scores, and it first asks us for the 5-number summary. 5-number summary is a set of 5 statistical values: minimum, quartile 1, median, quartile 3, and maximum. So we will need to solve for each one. The minimum is easy. We'll just find the smallest number in the set. And since it's in ascending order, we can pick out that 55 is the smallest. So 55 is our minimum. We can go ahead and find maximum the same way, since it's just the largest number. So our maximum would be 95. We're going to go ahead and skip to the median, and since there's an odd number of terms in this set, we can simply pick out the middle number, and that will be our median. So in this case, it is 70. If we want to double check, we can make sure there is the same amount of terms on either side of the median. So if we go to 70 and ignore it, we'll see that there's 5 on the left side and 5 on the right side. So that means that 70 is in fact our median. Now we can use the median to find Q1. So all we have to do is actually ignore it, kind of do what we just did to double check, and we just focus on the right side or the left side of the median for quartile 1. So if we ignore 70 and just look at these numbers, we can see that 62 is kind of our median, just focusing on that. So that's going to be our Q1. We can find Q3 the same way, except we are just focusing on the right side. So if we just look at these numbers, we can see that 80 is in the middle. So that is going to be our Q3. Now that we have all 5 values, we can move on to 2, which asks for us to find the IQR and to find outliers based on the 1.5 times IQR rule. For IQR, all we do is subtract Q1 from Q3, so the IQR would be 18. Now we can use this to find outliers. We're going to take our value for Q1, 62, and subtract 1.5 times the IQR. So it'll look like this. 62 minus 1.5 times 18, and that gives us 35. Then we're going to do Q3 plus 1.5 times IQR. So it'll look like this. 80 plus 1.5 times 18 equals 107. Now we have 35 and 107, so we can look at our data set and see if any numbers are lower than 35 or higher than 107. Since all our numbers are within these parameters, we have no outliers. So our QR was 18, and we had no outliers. Now we can move on to number 3, where we are asked to draw a box plot. So first, we create a number line that is applicable to our data. Since our data ranges from 55 to 95, I wrote my number line from 50 to 100, counting up by 5s. Then, we draw lines that are minimum and maximum numbers. So just like a little horizontal line above the numbers that we got for our minimum and maximum. Then, we draw lines at our Q1 and Q3, connecting them to the minimum and max. So, our minimum and our Q1 are going to have a line connecting the two, and our maximum and Q3 are going to have a line connecting the two. Then we draw a line at the median and connect all 3 lines to make our box in the middle. So we draw this line first, and then we connect these to make 2 boxes connecting in the middle. And this completes our box plot. We can see through the box plot that it is slightly right skewed, since the right tail is a little bit more stretched out. Now we can move on to problem 3. It states package weights shipped by a company are approximately normal with a mean of 12 pounds and standard deviation of 2 pounds. And it asks, what proportion of packages weigh between 10 and 14 pounds? For this problem, we are to use the 68, 95, 99.7 rule, which says about 68% of the data lies within 1 standard deviation of the mean, about 95% lies within 2 standard deviations, and about 99.7 lies within 3 standard deviations. So first, we'll find what proportion of packages weigh between 10 and 14 pounds. First, we can think about the numbers they gave us, that the mean is 12 and the standard deviation is 2. If we use these numbers to find where 10 and 14 lie, we can try 1 standard deviation. So to do this, we would subtract 2 from the mean, 12, and find that it is 10. If we try the same thing but add 12 plus 2, it gives us 14. This means that these numbers are then 1 standard deviation of the mean, and using the rule I explained earlier, we know that 68% of the packages would fall in this range. Now we can move on to number 2, which asks what proportion weigh more than 16 pounds. Now we have to figure out how many standard deviations 16 is above the mean. We can subtract 16 minus 12, which is the mean, and it gives us 4, leading us to make the conclusion that it is 2 standard deviations above the mean. Using this rule, we can say that 95% of the data lies between this range. But that is not the answer to our problem, since it asked what proportion weighs more than 16. But we can take the 95% that we got earlier and decide that 5% total on the outside, that there is 5% total on the outside. Since it asks for more than 16 though, we have to cut this in half, so it only accounts for the values above 16 and not below. This gives us our final answer of 2.5%. Looking at the bell curve can give us some sense into why these answers are true and how the 68, 95, 99.7 rule works into the problems. Moving on to our fourth and final problem, it states, assume math scores are normal with a mean of 500 and standard deviation of 100. Using this, it asks us to find the score that marks the top 10% of students. Top 10% means the cutoff has 90% of students below it. So our percentile would be p equals 0.9. So using this, we need to find numbers closest to 0.9000 in the body of our z-score table. I believe the closest numbers are 0.8997 and 0.9015. Now, this part can get a little complicated, but I'll explain it to the best of my abilities. First, I just started by writing the z-score and the corresponding decimal points so we know what we're working with. Then we set up an equation to find the exact z-score that corresponds to 0.9000, since we did not have an exact one in our table. This formula basically says to start at 1.28, corresponding to 0.8997, and then add the difference between the cumulative probabilities, like 0.915 and 0.8997, in order to use this answer in the next equation. The answer I got was 1.2816. Now we can convert our answer to SAT form, where I added the mean to the product of the z-score and standard deviations. This gives us our final answer of 628. Now we are asked to find the score that marks the bottom 25% of students. So we're going to find this the same way by first converting 25% to 0.2500. Now we find the probabilities from the table that are closest, which I found to be 0.2514 and 0.2483. Now we do the same kind of equation as last time to find a more exact z-score. So we set it up like we did last time with the z-score and the corresponding decimal points. And then when I set up the equation, I got my answer of negative 0.6745. So now we can plug this into the next equation to find the SAT score. And I got 433 as my final answer that marks the bottom 25% of student SAT scores. Now that we have solved all the problems, that concludes my video. I hope you learned a lot about some of the concepts of statistics.